We are at the Association of Old Crows convention in Washington, D.C. We are in the Tektronix booth, and Tektronix has this new oscilloscope, which they call a 4 Series B.
Yep.
And we will be doing a review, or I shouldn't say a review, a tryout of this. But these oscilloscopes have a lot of things, and I only had it for a few days, so I couldn't quite get to everything. But Daniel Schneider is going to give us a demonstration of two different ways to look at the same signal in the frequency domain.
Yep.
So Daniel, why don't you tell us what we've got here? It looks like we've got a signal that's got a little bit of a spread spectrum. You can see it bouncing around.
That is correct.
And we've also got some little overshoot, a little ringing on the top and bottom. So why don't you tell us about how we can look at this in the frequency domain?
Yeah. Well, we'll go ahead and start by taking a look at it with a traditional way that you would approach this problem with an oscilloscope, by taking a look with a FFT. So we can add our math channel, set that to the FFT, and one of the problems with FFTs is, well, you need to have a long record length in order to have your resolution. So let's get our scale out so we can actually resolve this. Open up our scaling menu. Let's say from 90 megahertz up to 110. Whoops, backspace, 110 meg. There we go. Now we've got it. But we can't really see anything that's happening in our time domain anymore.
Right.
Because we've zoomed out so far just so we can resolve our FFT.
Mm-hmm.
So I'll show you all the novel approach that Tektronix has taken by first default setting and then auto setting the oscilloscope.
Okay.
So now we're back to just where we were a minute ago.
Mm-hmm.
If we open up our channel badge, select spectrum view and turn it on, we're now greeted with another spectrum display.
Yep.
But more importantly, we have our new spectrum badge down here where we can independently control our spectrum from our time domain. So let's set our center frequency to 100 megahertz and drop our span down a little bit. We can also use our touch screen to slide that around and adjust as necessary. And what we can now see is our spectrum domain and our time domain optimized for both at the same time.
Okay.
One of the other benefits of spectrum view is that we also are able to use our frequency versus time demodulation. Grab a bit more of the time domain, we can see the demodulated here, and we can see that our spectrum is a triangular shape.
Mm-hmm.
Finally, one of the most impressive features in my book is that we can, because this is done in the ASIC with our DDC behind every single channel, we can then trigger on that demodulated frequency versus time trace.
So you can actually trigger on the demodulated signal.
Yes.
But this is a time domain plot of the frequency of that signal.
Yes.
Okay, so that's why when we were seeing what looked like jitter, it was because the frequency was in fact changing, and here's the plot
That is correct.
of it changing.